All right, and welcome to another exciting episode of AP Chemistry here at Spain Park High School. Today is Thursday, November the 7th. Okay, and we are here discussing Lewis dot structure. So if you're enjoying these videos, please be sure to subscribe to this channel and hit that like button. All right, here we go. We did number 1 already, but let's just kind of review it in terms of counting and just going through the process, because this is a good one for double bonds. Okay, so step 1 is to do what?
Count all the valence electrons.
Count the valence electrons. So we're going to have 6 and then 18, so we have 24 electrons. Does everybody, are we all comfortable with getting valence electrons and counting and how to do that? So I can just fly through that step, right? Okay. Central atom, what's the central atom going to be?
Sulfur.
Sulfur. So then you just build the oxygens. Don't worry about sulfur's atomic electron, dot structure, having the 6 and all of that kind of stuff. Just build with single bonds around it. Now we begin step 3, filling the octets on the peripheral with lone pair. Each line represents 6. So I have 2 electrons. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I've used up all my electrons. Now what's the issue here?
Like that.
Sulfur does not have a filled octet, but we're out of electrons. So that's what rule 4, I think, says, or it's rule 4 or 5 in the book. It says if the central atom does not have enough, if there's not enough electrons for the central atom to get 8 electrons, what do we have to do? Double bond. Now you steal from the rich. So you find the rich in terms of lone pair electrons. Now all 3 of these are equally rich. They all have 6 electrons, or 3 pair of lone pairs. So I can pick 2 any 2, and we're going to talk about this, but this is the phenomenon of resonance, but we'll talk about that when we get into more details of bonding. So I can pick 2 any 2, I can make the double bond. You may put the double bond here, you may put the double bond there, all 100% correct, it does not matter. So when the central atom is electron deficient, is the only time you're going to make a double bond. Don't just start making double bonds just for the fun of it. Okay? Only when the central atom doesn't have enough. All right, now here's another case. So I got 1 and I have 5, makes 6 and 12, so I have 18 electrons. What's my central atom going to be? Nitrogen. And here's where my rule comes in. You have nitrogen, oxygen, oxygen. When you have hydrogen and oxygen and some other nonmetal, the hydrogen is going to be attached to the oxygen, not to the nonmetal. Okay? Hydrogen is oxygen's hoe. They go together. They go together. Now, it doesn't matter which oxygen you put it on. So I'm just going to go here. So nitrogen, oxygen. So now I have 18 electrons. 2, 4, 6. Hydrogen doesn't need any more. Hydrogen's the only one that only needs 2. So you never put lone pair on the hydrogen, because it's the smallest atom. There's no more room.
So hydrogen can't form with nitrogen?
I've said it 3 times.
I know, I'm just like...
When you have hydrogen, nitrogen, and oxygen, the hydrogen is going to bond to the oxygen, not to the central atom. Hydrogen and oxygen have a thing for one another. Now, in a rare case, in an organic compound, they will tell you that, they'll put the hydrogen somewhere else, but for most of our substances, hydrogen is going to go on the oxygen. So, 2, 4, 6, 8, 10, 12, 14, 16. Put 2 on there, it's 18. So now I have 18 electrons. Well, again, what's the issue? Nitrogen doesn't have a complete octet, so I need to steal from the rich. Well, which one is richer? This oxygen or this oxygen?
The second.
This oxygen is richer. So we're going to steal from this one and make the double bond. And go here. Because technically, how many bonds is oxygen going to form? 2. It's got 2 unpaired electrons, so it's going to form 2 bonds. The halogens are all going to form how many bonds? 1. Okay? So if I try to do this, here. Now how many bonds is oxygen forming?
3.
3. It typically doesn't do that. Okay? You want it, so when you're looking at, okay, so I'm like this, I need to steal from the rich. Well, which one's richer? This one's got 3 lone pairs, this one only has 2 lone pairs, so I'm gonna steal from the richer. And so I'm gonna make my double bond here. Now we're gonna have another thing called formal charge, which is gonna help us identify, but just in doing basic Lewis dot structure, we just steal from the richer. Typically, halogens only form 1 bond, oxygen family form 2, nitrogen family forms 3, carbon forms 4 bonds. Okay? Because that's how many electrons they need to get that filled octet. So that's something that you need to also kind of keep in the back of your head all the time. Halogens 1 bond, oxygen family can form 2 singles or a double, nitrogen family can form a triple, a double and a single, or 3 singles. Carbon family can form 4 bonds, any kind of 4 singles, 2 doubles, a triple, and a single, however you get to 4. Okay? Silicon dioxide. So silicon, well, first off, has 4, and then 12, I have 16 electrons. So I'm just gonna go oxygen, oxygen. Now notice that I am putting them opposite each other if possible. And that's because we're gonna be learning the valence shell electron pair repulsion theory. The valence shell electron pairs repel and get the maximum distance apart. So we're going to start talking about the shapes of molecules here shortly. So we have SiO2. So now I have 16 electrons, 2, 4, 6, 8, 10, 12, 14, 16. Well, what's the issue?
Steal from the rich here.
Steal from the rich, but we don't need to steal all from the same guy, right? So oxygen typically is not going to form a triple bond. Okay, it really only wants to form 2 bonds. So I'm going to spread the wealth. So I'm going to form a double bond there. I'm going to form a double bond there. SiO2, which happens to be sand or quartz. Okay. Now, this is the space for it, but just so you can see better, I'm going to draw these above it instead of below it. All right. So Carter, what does that minus mean?
They gain an electron.
It gained an electron, so when we count electrons, so iodine has how many electrons, each iodine?
7.
7 times 3 is 21, but an extra one means I have 22 electrons. I'm actually gonna change my mind, I'm gonna draw it over here. So, now, what's gonna be my central iodine? Iodine, it's only, that's all you got, is iodine.
Why do you have 22 rows? Is it
Shouldn't
giving
it be
one?
24?
Because-
Yeah, shouldn't it be
It's
24?
charged.
Because the 8 times 3.
No, iodine has 7.
But if it gained an electron,
Each iodine can gain 1, the I3 gained 1. It's not times 3. It's the I3 minus 1. Okay? So it's gonna be iodine, iodine, iodine. 2, 4, 6, 8, 10, 12, 14, 16, 18. Well, now I got 4 extra electrons. Where do extra electrons always go? On the central atom, always in pairs. Now it doesn't matter where you put them, I'm just gonna try and go 1, 2, 4. Now when you have an ion, you have to put it in a bracket and put the charge on the outside. Now what's the significance of that? It means that the charge is evenly distributed on the whole thing. It's not on any particular iodine. Okay? The charge is even, it's a molecular orbital. It's the electrons are everywhere, and the minus 1 is on the whole thing, evenly distributed. Not just on any particular iodine. All right, moving on. Okay, I'm gonna start going faster. I know you guys gotta go, but I am videoing, so you can watch it later at your leisure. Okay? And what I would do if I was you guys is I would try to do as much of these on your own and then just come back and just kind of match up your answers. Just if you want to be the good ideal student. Okay? All right. So again, Cl2F2, what's gonna be? Well, first off, let's count. 4, and then we got 4 times 7 is 28, there's 32 electrons. Okay? What's my central atom gonna be?
Carbon.
Carbon. How did you know that, Carter?
He has the lowest amount of valence.
Go around the back. It has the lowest number, okay? So carbon, and it doesn't matter where you put these. Okay, you can put the chlorines and the fluorines anywhere, the order doesn't matter at all. Okay? And we're gonna find when we build these molecules later on, hopefully later today, okay? When we build these models, then we're gonna see that we end up getting, it won't matter where you put them. So I have 32, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 6, 28, 30, 32. Hey, stick a fork in it, you're done. That's easy. This is what we refer to as a chlorofluorocarbon, or a CFC. You'll hear about those in terms of environmental issues. Freon is a chlorofluorocarbon. Freon 12, which was the original refrigerant, had 2 carbons, and then had fluorines and chlorines on the 2 carbons with some hydrogens. It's a dichloro, difluoro, ethane, but it's a chlorofluorocarbon. Now they're very stable molecules. So what would happen is that when one of my first cars, well, that was my first car that was really mine, was a Chrysler Cordova. It was back when Chrysler made really crappy cars, and my air conditioner was bad. It was leaking. I could go to the auto parts store and I could just buy a can of Freon, and I would just put it into the car, and any Freon that I had could leak out. If somebody had to change the air conditioner, they would just let the Freon go, and then they would just replace it with new. Well, it turns out that these chlorofluorocarbons, has any of y'all ever heard of the hole in the ozone layer? That there's over Antarctica, there was a hole in the ozone layer. Well, it turns out that these chlorofluorocarbons, very stable, so they can exist in the atmosphere for a long time, and they just eventually work their way up into the upper atmosphere. And when they get high enough up, then the UV rays are strong enough then to start breaking the bonds, and the chlorines start coming off. And the chlorine would be what we call a free radical, and it would react with the ozone and destroy the ozone, react with the ozone and change it into oxygen, just O2. Ozone is O3. And it turned out that one chlorine atom can destroy up to 20,000 ozone molecules before itself reacted with something and then became less reactive. So they were blaming the whole hole in the ozone on these CFCs, and so they banned them. And they've gone now to all kinds, they've gone through about 3 or 4 different stages of freons that they put in the cars now. And if you ever buy a car and have to have an air conditioner worked on, or even your house, they have different types of freon depending upon how old your car is, because they're trying to always come out with more environmentally friendly forms of the freons, the CFCs, that are more stable. Plus, now anybody that works on a car or home air conditioner has to have a tank to where they drain the freon out of the system, and they don't just let it go into the atmosphere anymore. You always have to collect it. However, with the new stuff, I can now go to my wife's car. Actually has a very, very small leak in her air conditioner system. And so I can go to the auto parts store now, and with the new environmentally friendly, I can buy that, and they give you a little adapter, and I can actually add Freon to her car to get it back charged up so it's cooling in the summer. It also has a little stop leak stuff added to it, and I didn't have to add any this summer, and so I'm hoping that the stop leak fixed the little tiny leak that she had, because I haven't had to add any more, because one can of that stuff is about this big, it's like $50 for the Freon, so it's expensive. Anyway, but it'd be like $2,000 if I went and tried to get it fixed. All right, so that's just a little side note on CFCs, on what this is. So if you ever hear the term CFCs in terms of environmental, that's what it's talking about. Okay? All right. NF3. How many electrons does it have?
26.
26. Okay? So I'm going to have N, F, 1, 2, 3. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Where's my last 2 electrons go?
Lone pair.
On the nitrogen now, everything's got 8, it's easy.
So when you like don't have all your electrons used, that's when you do the lone pair. But then when you have all of them used, but the central atom doesn't have enough, that's when you do the double bond.
If there's not enough for the central atom to have them, that's when you do
But
the double
you
bond.
used all your electrons.
Yeah, you
but
use them all, but there's still not enough for the central atom.
Okay.
Okay, so no need to form a double bond here. Everybody's happy the way they are. If it ain't broke, don't fix it. All right.
Get a break.
No, we're gonna, as soon as we finish with this, I'll give you a break, and we'll be done.
Forever.
Well, for today. You guys know you love learning all this stuff, so quit whining about it. Okay, let's go faster. Okay, 7 times 4 is 28.
Yes.
So bromine, fluorine, 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 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. Okay, expand octet. SF6. As soon as you have 5 or 6, if there's ever a 5 or 6, you know it's expanded octet. But you still just build around. Now this is sulfur hexafluoride. This is pretty cool stuff. Although I've never gotten to do this personally. I've seen it. But you know how you breathe in helium from a balloon and you talk real high and funny? You've all done that, right?
That's the deep
Okay.
place.
This is sulfur hexafluoride. It is super dense. So if you breathe it in and talk, your voice gets super low. It just does the exact opposite of the helium and makes it sound really goofy. Okay. They also do things to where they fill like an aquarium tank full of the gas, and then you can kind of float things in it because the gas is so dense. Things that would normally sink in air will float in it and do kind of things. They do some of that on late night TV when they bring the science guy in. This is a classic science guy little demo because it's kind of cool. All right, ClO2, 14 and 6 is 20 electrons. Oxygen, chlorine, chlorine, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Easy. PCl5. Since I see a 5, I know I have an expanded octet. But I'm still just going to go 7 times 5 is 35 plus 5, I have 40 electrons. So I'm just going to say PCl, Cl, 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 Cl. 8 times 5 is 40. So I know everything's just going to have its octet. PCl5. SF4, we already did this one. It's going to look like this. I got 2 more electrons because there's 34 electrons. So where do the next 2 electrons go?
S.
On the S. Alright, so now HCN. 1 plus 4 makes 5 plus 5. I have 10 electrons. Okay? HCN, 10 electrons. What's my central atom going to be? Carbon. Now, hydrogen, I know hydrogen's never going to be the central atom. But how do I know between carbon and nitrogen? Least valence electrons. This has 4 versus 5. So the least number of valence electrons is my central atom. So you get carbon, hydrogen to nitrogen. So 2, 4. Hydrogen doesn't need any more. 2, 4, 6, 8, 10. Well, now we have a big issue. Carbon only has 4.
How does the nitrogen have 6 electrons and then it's also bonded with the carbon? Because I thought nitrogen had 5.
Once again, we don't worry about the source of the electrons to start with.
Okay.
Okay, we're just counting the total 10. Now, if you want to build it the way you're thinking, okay, we have carbon has 4 valence electrons. You put a hydrogen in here. Nitrogen has 5 valence electrons. It would look like that. Okay? Well, they have 2 unpaired here. You can share there, you share there, and you share there, and you end up getting the triple bond. But if you just do this, this is the way I recommend you do it, you're just gonna end up having carbon, okay, it needs how many more electrons? It's 2, 4, it needs 6, 8, so we're gonna actually form the triple bond right here, and it's gonna look like that. But it's gonna be the same thing that we're gonna get right here, like that. Now, hydrogen cyanide, that's the gas they use in the gas chamber. Okay, you breathe it, supposedly it smells like almonds, but it affects your central nervous system and causes all of your involuntary muscles, like your breathing and your heart and all those things, to go into spasms, and then you die. I don't know if all the foaming at the mouth is all real, like the poison pills that the spies always take to kill themselves before they get captured. I don't think it makes you foam at the mouth like that. I think that's Hollywood.
Let's try it.
You go first.
I don't want
We should like draw straws.
Yes. Then they like Hunger Games or whatever, it's on draw straws, he dies. All right, well, again, what does the minus mean?
Plus 1 electron.
1 electron, so selenium has 6, bromine has 7, so 21 plus 6 is 27, plus 1 is 28. Se, Br, 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 okay? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. Okay? I mean, don't make it hard. Count your electrons, build around the central atom, and then just fill them in. Okay? Don't overthink. KrF4. Now, krypton is a noble gas, so I know it's going to be expanded octet. But again, I don't worry about where the electrons are coming from. Fluorine, 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 fluorine. Sam, you have a question?
Yeah, aren't you supposed to do like the brackets?
Yes, you are supposed to do the brackets. Thank you. I'm trying to rush.
For Krypton?
No, for this one, because the charge out here. Okay, so here's 8 times 4 is 32. Well, I have 8 and plus 7 times 4 is 28. 28 plus 8 makes 36 electrons, right?
See.
So I have 32 accounted for, so what else do I need to do? Now, and again, it doesn't matter where, but again, always put them in pair. Don't go 1, 2, 3, 4 around. The electrons are always in pairs. Always in pairs. And then lastly, what's unique about 15?
It needs 6.
Boron. It's family 13.
Oh.
Okay? Because here's what most people are going to want to do. So it's got 7 times 3 is 21, plus 3 is 24 electrons. So you're going to say boron, fluorine, fluorine, fluorine. You're going to get this. 8 times 3 is 24. But you're going to say, oh, boron needs another electron. So everybody's going to want to do this and make a double bond. Well, there are 2 problems with that. Number 1, boron only needs 6. It does not need 8. I don't need a unit. I'm all right. Okay? Boron only needs 6. It's an exception to the octet rule. What's the second problem with this?
Fluorine only forms 1 bond.
Fluorine doesn't form double bonds. Halogens only form 1 bond. So we have to just recognize that group 13 is stable with just 6. You just have to be able to recognize it. Somehow, some way, you have to have an alarm system, boron, aluminum, gallium. Boron, aluminum, gallium, alarm system only needs 6. Okay? All right. Now, what we need to do next, what we need to do next is we're going to start talking then about the shapes of these molecules based upon these Lewis dot structures. Okay? Now, there's going to be a ton of memorization involved with this. I'm sorry, but AP requires you to know the shapes and the bond angles. But it's all based upon the Lewis dot structure. If you get some kind of mental picture. So tomorrow, we're going to come in on a Happy Friday, and we're going to look at the shapes of these. We're going to actually build them with a model so we can see the shapes, and just try to be able to do that. Then we're going to get into next week the mechanics. I'm gonna kind of skip over a whole section of notes, but then we're going to get into the mechanics of how they bond, and then talk about this thing called hybridization, resonance and all these other things, okay? But I hope that we're gonna be finished 100% by the end of next week. And, I would even love to maybe even think that we could have a test by the end of next week, if not by the beginning of that next week. Okay, we're definitely having a test over this before Thanksgiving.
Okay.
Definitely having a test before Thanksgiving, okay. All right, thanks y'all, and go Jags.